Now that we got the shoulders lifting, I went ahead and I took the front plate or chest plate, whatever you want to call it, off. And the next step is we got to get the shoulders rotating like this here. So basically this whole guy turning. And remember, we got the CV axle that goes through here. So when I turn this CV axle, you know, it's going to go ahead and rotate the shoulder. I've been doing different experiments. I made this linkage. Now I got this guy, and goes there like that. And so now what you get when you tighten this linkage on is as the linkage goes up and down, you get your movement. Now the stepper motors, I've been experimenting with different ones, as you guys can see from the welding marks here. Do we use stuff with more gears and less amperage? Yeah, like this guy here, large gear set here. Yeah, but fairly small motor. Or on this hand, no gears at all. A lot of amperage. In the end, with the gearing at about 15:1, which is what this guy is. This is actually a low accuracy one I was using for experiments. But it pulls almost 2 amps, 1.8, and it's got the 15:1 gearing. And I really like the 15:1 gearing because it gives you movement about as fast as a human can move, but not a lot of RPM. So it's really, a lot of it's in the torque here. You got a lot of torque with the 15:1. And so I found just having a bracket right here. You can see where I've done some welding, experimented with different brackets. And this guy here. And then we get our motion like that. And that worked out really well in testing. This is a low accuracy motor I was using for testing. So what we're going to end up with is a NEMA 23 mounting pattern right here for a NEMA 23, but with a gear head on it. Got that ordered, hasn't showed up yet, but we do know that a NEMA 23 is going here. So we're going to do that bracketry now, and that would get us on the way to having the rotation of the shoulders as well as the lift. Got these two 3x5 plates. They'll be perfect for making the NEMA 23 mounting patterns in. So I'm going to drill a pilot hole, and then we'll cut with this hole saw, 1.5 inches, which is what we need for this pattern here that you see on the NEMA 23s. Okay, a little crude, but there it is. Got our 1.5 inch holes. The next thing we got to do is drill the 4 holes to mount the stepper. And clean off the burrs from the drilling. And there we have it. We have 2 NEMA 23 mounting patterns. Hopefully. I was going to mess it up. Now that we got those NEMA 23 patterns in there, next up is cutting the rounded edges. It's just for cosmetics, but gonna slice those out. Alright, got the bolts all tightened up on there. Give you guys a good shot. Sorry, it's kind of darker over here. Now I'm gonna clamp it on. Got those brackets welded on there in a test fashion anyways. Once we know we love them, we'll weld it all better, like I've said. But alright, there's our two NEMA 23 brackets. Got the proper motor set up here. 15 to 1 gearbox. This is a little over 2 amp motor. If I need more power, more torque, I can always increase this motor to one that uses more amperage. But so far this has been a winning combination in tests. I like the 15 to 1, like I said, because it gives you the human motion speed, but saves all the rest of the RPM of the motor for torque, which, you know, you need a lot of torque for a project like this, where we're just pushing levers a quarter turn, but it's got to be a tough quarter turn. This, I don't know how much welding and grinding you guys want to watch, so I didn't film it, but you know, here's the little levers that I made, the little keyway. It's effectively a plate, you know, a collar. I ground a little keyway in it and zapped them together. So there's the collar with a keyway ground in it, zapped together with the plate. I drilled a couple of holes on this end. It dramatically changes the speed and the torque. You know, as you go farther away from the shaft, you increase the speed, of course, of, you know, how fast you're moving the arm, but you lose torque dramatically. So I was experimenting there. Had these two holes here because I thought I was going to have to bolt on a collar, but I found these in 14, so I'm real happy. Zapped them on just also in a temporary fashion. But yeah, let's go ahead and mount the stepper motors, and let's see these arms, shoulders at least, moving around. Yeah. Alright. And just like that, we got the 2 geared stepper motors that are going to do the rotation of the shoulders. So next up is let's go ahead and put our linkage on. Now again, you guys have seen, but from the end of the CV axle to the shaft of the stepper. So here's that linkage I got set up. I'm going to put it together real quick there. Okay, well, with the further out hole, a little more speed, a little less torque. I'm going to put 2 washers here, and it gives the ball joint a little bit more room to move. And then we're so tight on space, it doesn't get any other washers unless we have to. Alright, there's that end. Tie rod in, all thread. The other end I actually had to put a countersunk in there, screw, because the tolerances are so tight inside where it goes. Shave that off nice and even. Let's put it on. Alright, linkage. Top and bottom nice into the keyway. This handy dandy little guy here. Yeah, and just like that, we got some linkage as the stepper motor turns. Turn the CV axle. CV axle will then turn the shoulder, rotate the shoulder. I'm going to bolt up the other side, do the same thing. I won't bore you guys with it. But our next step, sorry about that, our next step is to mount some switches so we can zero out these axes. Basically when the robot boots up, the computer has no idea where anything is, and so it'll slowly move itself until it finds those switches, and when it hits those switches it'll know, okay, I'm going to set that as 0. So I'm going to probably put them right here as they're kind of tucked in hopefully relatively safe. These ones actually sit underneath the levers up here, as you guys will see, so they're not so bad. But yeah, we got our steppers on there, we got our linkage. And now, time for the switches. Now let me give you guys a better look at these limit switches. We got to get on here to zero out our positions. This is basically momentary contact switch. It's got the normally open and normally closed terminals. But just for testing purposes, I did some measuring with our cam, or lever, whatever you want to call it. And it seems like right here, when this thing comes around, it'll click it and that'll be the zero position. Just for testing purposes, I just barely tack welded a T-channel nut on there. And we're going to screw that on there right now. Alright, good deal on the switch. So now it's time to really start to put this robot together and give it a test. I'm going to put the front plate and back plate back on it and put all this linkage on and test it out. Yeah, linkage on the other side, or excuse me, the switch. So let me rotate the shoulder. Aha! Beautiful. That'll be the shoulder all the way down, and then we'll be able to zero out with that switch. So take a look at this. There's both of our linkage rods. You got it going all the way up right here. And there's the second one. And the linkage up in there. Up and down they go. Alright, now we'll put the back plate back on it. Okay. Back plate's a little bit of a wiggle on there. We got so many things to line up, but it does alright. Look at this linkage. You guys have seen me do the linkage before. Pretty simple. I'll show you guys again too. There's that little lever that hits the switch. We can adjust and spin it like a cam. There's the activation of that switch. Awesome. Tighten up some Allens. Good enough. See what happens when we lift the shoulder. Alright. Got our switch activated when we get all the way down, zero out. And with this guy. So now that's all four. So we're seeing that 1, 2, and 3, 4 main NEMA 23 steppers, all pretty much dedicated to lifting and rotating the shoulders. I'm going to go ahead and drop the wires. All the stepper cabling is actually going to drop down the spine right here. So we're going to drop all these down now, and they come out the bottom of the seat where all the electronics are going to be down here. So let's do that now. Probably hard to see, but on the side of the spine here, I got some holes for the sensors and the lower stepper motors down here to get down there to the bottom. Cool thing about the design of this robot having this center spine is it makes the wiring kind of convenient. And all you gotta do is get into the spine and you're where you need to be. Right now you guys are going to see a rough draft of the arms. I wanted to go ahead and throw a rough draft arm on there, so in the shoulder demonstration of the shoulders moving, I wanted you guys to get to, of course, see them under load. Don't count it once you see how it works under load. So here it is. Give you a shot right about there, that way. Pretty cool. I like how smooth it is. I mean, those all those drivers down there are digital drivers. They are, the newer of the style that just get mounted into a panel or whatnot. And I am pretty happy with them. And it's all too easy to program the Arduino in C to get all these components going, or steppers going in the direction they need to go. And so I'm pretty happy with this setup. But you're going to see an episode of just all the electronics and a couple different driver board styles, and we're going to try this robot out in Python, all on the NVIDIA Nano. That way we get a lot more power and options, and we're going to do it all in C, and we're going to try all kinds of different options. But I wanted you guys to check out the shoulders. This other one obviously moves the same. Let me give you guys a up-close shot of that. I still got the chest plate off, obviously, so you guys can see the levers and things moving. Rotation. And one thing I'm really happy about this current driver board setup is, I have the space for it down there. As you saw, everything down there fit. And there's 20 of them buggers, but 18 of them to be specific, but there's 2 more in the legs that are cosmetic. But there's 18 of them and they fit. And I've had the robot, what equipment you see, all the steppers and NEMA 23s around here now, I've set them to just run random for hours and hours and hours, and they just keep going to random spots and random speeds. And I haven't had any heat issues. It stays very cool down there. I'm very happy. The the 3 Meanwell power supplies that you guys saw down there are, 2 different voltages. One is a 24, and it's going to power all the smaller stepper motors. And then the other 2 power supplies are 36 volts, and for powering the larger steppers. But yeah, there it is. The next episode, we're going to actually do an arm for real. This is a rough draft. I want you guys to see the thing move under load. So there it is. And this arm actually does work. I've been testing it. But it's very rudimentary. I just wanted to put things in the exact right spot. But the next episode, we're going to build an arm. So stay tuned. And we're going to keep going with this. Thank you guys.